Hi. Welcome. I am Kathleen McMahon. I'm a front-end engineer at O'Reilly Media, and I work on the design system. I have a couple coworkers here who also work on it. We're pretty awesome. And another coworker who's been doing some really awesome stuff, contributing to it. So it's an internal open source project. You may know of O'Reilly as the animal book people, but we're more than that. We are a learning platform, an online learning platform. So I'm here to talk to you today about how you can flavor your React components with accessibility seasonings to make your design system delicious. So before we get started, here's an outline of the topics we'll talk about today: why we use React, why accessible components, your design systems are a cookbook, design systems in React. We'll talk about how to make icons, buttons, and inputs accessible, a little bit of guidance on documentation, and then we'll wrap it up. So, why use React? Technically, you don't have to. Really. Some design systems use HTML, CSS. Most I've seen use HTML, CSS, and JavaScript. Lots of those tend to also use a framework like React. There are some curated lists of different design systems. My favorite one is Adele by UXPen. And I'm going to jump over here for a second so you can see some things here. This is a really cool, it's like this sortable list of all the design systems that UXPen has curated. This list is pretty great. If you look at the code depth column, you'll see HTML, CSS, JavaScript. Some are just HTML, CSS. And you will see whether it's using a library or framework or not. More often than not, you are seeing, if it's a framework, it's React, the latest hotness. So if you've been in the industry for a while, you see this pattern of the latest hotness. This software is so hot this year, everyone's using it, and then next year there's a new hotness. So you may also see this demand for framework knowledge. If you are an industry veteran, or if you're coming out of a boot camp. I am both. I have worked in the industry a long time, but I also did the boot camp. So what you've seen when you're in this industry is the amount of frameworks that come up are released are exponentially fast. And if you don't keep up, you feel very left behind. Now, don't get me wrong. Knowing how to make kick-ass experiences using HTML, CSS, and JavaScript is a very important skill. It's like the fundamentals. That is the bread and butter that you need. On the other hand, if you want to maximize the amount of opportunities available to you, whoops, we'll go over there. Right to the right thing. See? Nerves. You have to. Let's try it again. Go where the work is. So, we can't be privileged enough to just say, oh, everyone will hire me. You have to learn the skills. You have to level up. And sometimes that can feel overwhelming, depending on where you come from, either boot camp or if you've been doing this for a long time. If you have what some people call old school skills, you can start feeling like a dinosaur. And that can trigger a little bit of fear and panic, like my favorite gif of panically Natalie Portman sobbing in a corner. And that's natural, because we all want to stay relevant, but fear not. You know what? Dinosaurs are awesome, because dinosaurs are always the hotness. Just, you can be that dinosaur doing a flip in the pool. So those old school HTML, CSS, and our skills are highly valuable, and as well as those vanilla JavaScript skills, they transfer no matter what framework you do. And they give you an edge in the industry. Thank you for coming to my talk. I'm kidding. So, why accessible components? I have these skills, why accessible? Well, we don't want to leave our users behind. And we want to be able to empower our engineers to be able to create accessible apps by providing accessible hooks into our components. So we have, our users are diverse, they're varied. They all have different needs. We all have different needs depending on what we're born with, our situation, or circumstances, or our preferences. Some users have low or no vision. Some users are deaf or hard of hearing. Like, think of vision. You also could be in a bright room, hard of hearing. You could be deaf, but you could also be in a loud bar on your laptop. It happens. You could have a motor control issue where you have a hand tremor, Parkinson's disease, you can't control that mouse. Or cognitive issues, so what if you have a learning disability? Sensory issues, what if you get migraines or vertigo? Language. What if the content you're seeing is not in your first language? And lastly, but not leastly, low bandwidth. There are users in other countries that they have to go to an internet cafe and download all their content because they're paying for bandwidth. And so they're downloading it all at once, and that market's just gonna get bigger, so hugely important. Our users are accessing their content in many ways. They're looking at our stuff on desktop and mobile. They are using a screen reader to read everything on the screen. They are zooming in the screen with a magnification software. They use a mouse, they can use a trackpad, but they also use keyboards. There are standard keyboards, there are Braille keyboards, and there are Morse code keyboards. There are users that use straw devices. I believe you blow one in it and you can like tick your head left and right. Switch controls, it's almost like a paddle. So tab and enter, yes. And voice assistants now. Alexa and Siri can be used as assistive technology. So the W3 has made these web content accessibility guidelines to help us create accessible apps. It's called WCAG for short. There are 3 levels of conformance. Single A, which is the minimum, double A, which is the gold standard, and triple A, which is the holy grail. You'd love it, but take what you can get and still wish for it. Right now, WCAG 2.1, that was released in 2018. That is the latest and greatest. WCAG 1 was released around 1999, 2 was in 2008, and 2.1 is 2018, which is now thinking about more of mobile devices and all these different scenarios, which is pretty great to think about. So there are 4 principles of accessibility that we have to think about with our apps. We have to make sure that our apps are perceivable by the user can operate them, it's understandable to the user, and it's robust enough that the user can access everything in many ways. So, especially assistive technology. Easiest way to remind yourself of this is pour yourself a cup of coffee, P-O-U-R. So, design system, it's a collection of reusable components guided by clear standards, and that could be assembled together to build any number of applications. Think flexibility, but it's also following your brand. I like to think of your design system as a cookbook. Hi, Paul. Hey. And your cookbooks have a personality. So my mom is a serious fan of cooking. And lately I've been enjoying digging through all her cookbooks that she's collected over the years. Hence all the graphics here. And I like to read how some of the recipes have evolved over time. If you've ever taken a look at some of the cookbooks published in the 1940s through 60s, other than like the meat jelly, interesting meat jelly, and you know what I'm talking about. Okay, you will find some serious attention to detail paid to the structure of every single part of the cooking process. For example, here's a quote I ran across in the foreword of the Culinary Arts Institute's encyclopedic cookbook that I found relevant to design systems in particular. If you're following a cookbook model, the personality of cookbook is as apparent as it is important. It is composed of known and stable ingredients with unknown and elusive ones to make a mixture of familiar, friendly, and exhilarating as a pine woods early on a summer morning. Very detailed, but if you're reading that with a screen reader, it sounds so nice. Okay, so let's get into design systems in React. Our design system uses React to build our components. And recently there's been a little bit of a philosophical debate about how using a JavaScript framework to create a product creates inaccessible apps. But if you look at React's page on accessibility, you'll read this: React fully supports building accessible websites by using standard HTML and CSS techniques. This is where those HTML and CSS fundamentals are so important. Not divs everywhere. A better way to think of React is going to consider it a kitchen utensil. It is not the only utensil in your kitchen. So React is like a kitchen utensil, and you are the cook. So in my opinion, it's up to the developer to have that standard HTML, CSS, and JavaScript and accessibility best practices knowledge to be able to leverage a utensil correctly. And that includes React. So components are your tried and true recipes. WCAG is your reference material because it is very encyclopedic. And our cookbook's in beta. Just letting you know. I just, want to make sure you know that we are always optimizing our components. So we are making sure as a team that we are prioritizing adding accessibility at the beginning of our product lifecycle and aren't releasing any components into the production environment until they're fully tested. We're also constantly retesting these components to make sure new bugs aren't introduced. Because browsers change, browsers introduce bugs. System technology introduces bugs. You need to continually test these things. It's not a one and done thing, continuous process. But I'm thrilled that this is a priority on our team because it allows us to build quality upfront rather than increasing product life cycles down the line, doing the we'll fix it later. And then it never gets done and it gets expensive and it's just pushed to the wayside. So creating a component is like following a recipe. First, you start with high quality ingredients. That's Semantic HTML. Get a lot of things for free with Semantic HTML. You mix in some key accessibility seasonings, which is ARIA, which is accessible, rich internet applications. It's a spec that you need to follow, but just a touch. If you ever read this really great article by that guy over there, Eric Bailey, he made an article, it's called, I think it's a CSS Tricks article. ARIA is spackle, it's not rebar. So I would highly recommend you checking that one out. You should follow the directions, so provide some good documentation and provide some helpful hints and usage guidelines, best practices for your developers. Let's start with icons now. Icons are a great way to add a bit of flourish to your product. Take my time, we're good. So icons are used to supplement key messaging, and they're used to identify content types and call attention to areas of importance. So icons can be informative or decorative. Informative icons need descriptive text. If they are providing some sort of informative function, it has to have text in there. Decorative icons that are presentational, they need to be hidden from screen readers, and you use the ARIA hidden attribute to do that. So for an accessible icon component, there are two schools of thought for doing this, and there is two hotness. The icon fonts used to be the hotness, SVGs are the hotness right now. We originally used SVGs and created some sprite sheets and had our accessible components using SVGs, and then we ran into a bug in VoiceOver in Safari using High Sierra. So everything was announcing in our sprite sheet on the page. It was awesome. So while that bug was being addressed, we decided to temporarily go the icon font route. So we took our SVGs and converted them into icons to use them in a different way by applying CSS classes and injecting content into spans. And we will be going back to SVG icons in the future. We just want to find a better way to do that. So let's look at an example. Make sure I have the right button. Okay, so this is Semantic HTML using an icon font pattern. Right now you have a span with a class of icon. This is, for us, our class of icon is letting the design system know we're using the icon class. And we apply the icon font as a pseudo element, so we inject this content before the span, which is /F1 12F, which really means it looks like an email, but the text looks like that. That's not great for screen readers, so what we do is make a companion span next to this span, sibling span, and we add some descriptive text. We're going to pair these two spans together. And then we wrap these spans, and we add some CSS to change the display property to inline block. The native display property for span is inline. An inline, a display of inline will only allow you to set padding and margin to the left and the right of the element. When you do inline block, you can manipulate the padding on all four sides. So it's a very important distinction, but it's also still inline, which is great. So high quality HTML, but the screen reader right now, if you read out this, you'd hear /F12F email. Like, woo, that's kind of noisy. So let's make this better. First, we sprinkle in a little bit of ARIA seasoning. So we add to the icon, the span with the icon class in there, we add an ARIA hidden equals true attribute. That will hide the icon font from reading out to the screen reader. And then we add to the second span, which has a descriptive text, a visually hidden class, which is not the one weird trick, but one common trick you use to take a span, hide it from sighted users, but still expose it to screen reader users. So when a screen reader traverses this container, they will hear just email. So the question is to hide or not to hide. You add to the wrapper span the ARIA hidden equals true attribute if this icon is intended to be used as a decorative icon. So screen readers will not hear it. This is more presentential, like little flourish that really doesn't have more value than a flourish. If this is an informative icon, you don't add the ARIA hidden attribute to this wrapper. When you do add this ARIA hidden equals true attribute, it hides all the children. So look that up. It does. It hides the children. So this is semantic HTML. This is semantic and accessible HTML. Let's see how it looks in React. Let's pop it into React. This is a React class component. And this is the React render function. Now I'm going to read so I don't forget. This is what the function looks like. The render function provides the instructions for the shape of the component that will be rendered into the DOM as HTML. Think of it like React giving the browser instructions for what should be rendered to the page. It's basically saying, hey, dear React, make the UI look like this, please. And React is always checking for this. It's called reconciliation. It's always checking to see if something changes. It's looking for this render function. So this is a block of JSX syntax. JSX is a JavaScript extension used in React that allows us to write JavaScript that looks like HTML, but is compiled into JavaScript and creates a visual representation of HTML elements, what the HTML will look like in the DOM. Basically, under the hood, this JSX looks like that. So it's the same. But if you are a visual person, this can look a little bit like Mom Spaghetti, which is why, thank you, Skim. I have someone who has had some good GIF game, and this is the second one. Thank you, Skim, for the Mom Spaghetti GIF. And so this is why it's great to be able to write things in JSX, because it looks like that happy home of HTML. So back to JSX. This is the difference between HTML and JSX for class. You say class name. And that empty span right there, if you have the span and you have nothing inside between the opening and closing element tags, you can escape it out like that, which is like old school XML syntax. And this is how that renders in HTML. You write it like this, you get the same thing. The beauty of semantics. You get stuff for free. I love things for free. So this is a good reason why thorough knowledge of semantic HTML will benefit you if you're using React as your component implementation tool or any other framework. And it's, in my opinion, an edge in getting employed. I will die on that hill. So looking back at the React component, here's our JSX. We are now declaring some incoming props. We are allowing the developer, when they use our component, to pass in these type of props into our component. And, well, we'll look at that for a second. So the developer can tell the component whether they want to have the icon hidden, what icon name they want to use, and if they want to pass in a custom icon title name to their icon for that descriptive text. And to make sure that your developers that are using your components are always using the accessibility features you've mixed in, you add those component guardrails. For example, this one. If a user passes in the icon hidden attribute and they set icon hidden to true, the span will render out aria hidden equals true. There's some fanciness under the hood that, well, in HTML, if you want to pass something as aria hidden, you don't go aria hidden is true or false. Because in like some older assistive technology, from what I understand, in certain scenarios, that will still render out as true. So you either want to, on your render component, you either want to have aria hidden equals true or nothing at all. And this is the pattern that you do it. So you either pass in, this is called a ternary expression. So if the developer passes in our icon hidden is true, nope. Is there a little I-beam? Anyway, I'll find out later. So if the icon hidden is true, aria hidden is rendered as true. If not, aria hidden is null. And when you look under the hood of that messy object of JSX, that means don't even render aria hidden into this span when it's HTML. So it's a pretty cool pattern. Second guardrail we're adding is if a developer passes in an icon name and that icon doesn't exist in our library, this component doesn't render at all. The third guardrail we add is if the developer does not pass in a custom descriptive text for their icon, we will automatically render the descriptive name that is associated with the icon file under the hood. So there's always descriptive text. In your documentation, you always should add some helpful hints of how to implement your components along with what it looks like and what props you should be passing in. So this is a decorative icon. As you can see, we're passing an icon hidden is true. The custom text icon, you pass in title of monocle on a stick. That icon will read out monocle on a stick. It won't read out search anymore. Back here, icon will read out as search. Here it will read out as nothing. So let's jump in over to buttons. So buttons perform an action on the page. Buttons should look like and act like a button. Not a link. Not a link. You should use Semantic HTML because you get a lot of screen reader and keyboard functionality for free. Because why would you use div role equals button on click, do this and do that? Because if you were here a year ago, there was this great presentation on accessibility and this card component, and it was by Scott O'Hara. And he had this quote, and it stuck with me, which is why I tweeted it, screenshot it. But it is, markup has a meaning, there is no spec for div, use it for whatever. Ever. There is no spec for that. Let's go over an example of how we make an accessible button component. First, we start off with a high quality ingredient, the button element. Right here, we have a button, we have class of root, we have some text side there. Because it's a button element, we have native keyboard interaction support. We don't have to add any other fancy whiz-bang things. You hit tab, it will focus right on your button. Yay, semantics. What's awesome is our UX designer has provided us with some mock-ups and has considered the default, hover, focus, and active states. We're missing the active states there. And we have a disabled button state there. And all of these are passing WCAG, AA, color contrast, success criteria, which is text over background, which it needs to be 4.5 to 1, and the borders of the interactive controls over the background, which can be relaxed to a contrast ratio of 3 to 1. So with that, in our CSS, we can leverage our pseudo classes to just leverage what CSS gives us for free. You don't have to toggle on classes or anything else. It's basically you take that root class and you add these pseudo classes in there, and since it's a native focusable keyboard, a focusable button, when you start tabbing around and clicking on it, you will see all this magical stuff. This is also, we're using a little bit of post CSS too, and CSS variables, so good times. We also have an ARIA label added here. We sprinkled that on a little bit in case you have this button. Say you have a page with 5 read more buttons. If you have a user that's relying on a keyboard, a screen reader, they're going to hear read more, read more, read more, read more. They're going to know where they are. So you can add this ARIA label, and you can dynamically start adding in different labels. So when you are navigating this particular button with a screen reader, you will hear read about dinosaurs rather than read more. So you have a little more context of where you are on the page. This is the class we apply to the button in HTML, and there it is in JSX. And if we want to add, say we want to add an icon into our button, we pop in that icon component here. And we're making sure the icon is always hidden here because the icon here is decorative. We always want that visible text in this button, in our case. And we also have the icon name support. We wrap these the button text and the icon in a span so we can have that flexbox support. We want to do some flexbox magic with our buttons. And then we refactor that first area, which is that send an email, as a template string called children. So React supports this children prop that whenever you pass something into the button, the child is just like, okay, you have like looks like a button element, you pass in some text in there. It's like, oh, that's the children. I will render that. We add some on-click handler support. So the developer that uses this, they can pass in any function they want. So whenever the button is clicked, it will handle whichever, it's flexible, whichever function that's passed in, not anything very specific. We're trying to lift the state up to make it usable in any scenario that we cannot think of. We also add in that pattern of, if we want the button to be disabled, the user can pass in disabled as true, and if not, it will be not rendered as disabled. So we're adding that flexibility for the developer to implement it at will. We also add some prop support, so we're passing in these props of like an ARIA label instead of just having read more about dinosaurs. It's more flexible when you're mapping buttons over different parts of the page. If they're children, icon name on click, and disabled. And then we pop that snippet into the render function. And we do some guardrails. No icon name, you don't get an icon. Sorry. And you provide your helpful hints for your buttons. So we have, if we want a feature button, if you have an example for an icon button, if you have one for a custom icon title, which is we should delete this because this is old. And then we're going to go over to inputs. Now, inputs need labels and error messages. Those are key ingredients to inputs. Labeled inputs give users more context. Labels, labels, labels. Label your inputs. Placeholders are not labels. They are not. Another article by Eric Bailey, because he is killing it with all the articles lately. And that's on a Smashing Magazine article on placeholders are not. Right? Smashing Magazine? CSS tricks. Smashing. See? It's in my vault of all the bookmarks I have. So it's really great. He has a really great article on why placeholders are not labels. You should use labels instead, because the minute you click in that input, users are like, where am I? They need the context of why they're adding in some some text. You don't want to cause any confusion. Placeholders are hard to style across browsers. Placeholders are not auto-translated. Also, with your inputs, make sure your inputs aren't too wide. Make sure that the max input width is 80 characters. Put your labels above your inputs and your error messages below your inputs. Think of your users that are zooming into at least 200%. What if that user has to scroll all the way to the right to find something and they just see this empty input because the label is to the left or somewhere else? You lost your context there. So don't make your inputs too wide. Put your labels above. Put your errors below. And if you have groups of inputs, group them in a field set. It's a glorious thing, and add a legend. If you do the work for the screen reader will say you have 5 inputs in there, and their inputs about like your favorite fruit or something like that. Or other things. It will say, fruits that you want to order, like input 1 of 5. And it will traverse across when you're clicking through with the screen reader. It'll give you context as you're hearing of where you are in this form. It's pretty awesome. This eye chart, I promise I will zoom in, is how we've handled a label in React. So let's start off with the key ingredients first. So this is a label in HTML. We have a label surrounding an input, and we have a span inside that label because we're using a floating label pattern for reasons. And we also have below this implicitly labeled input, we have a div with a span that will have our error text. This is how you can structure a label with HTML. To make this label more accessible, technically you don't have to do this because the input's inside the label, but we do it just in case later on we take the label input away outside of the label. You add a for attribute to the label, and you add an ID to the input, and both of the values for the for and the ID match. This is how screen readers can associate a label with an input. We also add label text. I forget why I highlighted it, so we'll move on. We sprinkle a little bit of ARIA in here to make sure that we can, eventually we're gonna dynamically make sure because this is gonna be a flexible input, we're gonna have an ARIA required attribute of whether this input will be required to fill out by users. The ARIA described by is used for if the error message comes up, that error few matches the ID of the error text. So the screen reader will know what to read out when the ARIA invalid attribute is set to true. And lastly, we sprinkle a little bit of ARIA live announcement to give the screen reader user a little guidance if there's an error in their message. It's a polite message. So when everything else loads on the page, or you finish entering something input, then you will get that message of, hey, something's wrong. We're not using the ARIA live equals assertive, or I believe rude. Don't do that. Keep it polite. Let's not interrupt the flow. This is how you do in JSX. The label for attribute is now HTML4. Class is now class name. Disable, we're using that disable pattern. We're adding on change and on key press handlers. That's a React thing of like, oh, if you change something, do things here. If you press the key, do things here. And then the ARIA required, described by, and invalid, they are dependent on whether the developer, when they implement this input, whether they're doing some sort of validation checking at the parent level. So those never show up unless they are true. And if they are true, the error wrapper will also show up. And I will show you that in a minute with our guardrails. So here, this is our guardrails. 1, no label, no input at all. No icon in your input. Here, you have to make sure that if you are doing some sort of validation handling with your input, you also have to pass in error text. So you have to make sure you're giving a description. Otherwise, that error message won't even render. So it's a nice little guardrail. And you get your helpful hints on how to implement inputs with examples. Disabled inputs are important too. And document. It's something you have to continually improve. Get feedback from your users, making sure you're getting a lot of examples, get pattern galleries, making sure you're implementing your components in different ways. For example, you can have some do's and don'ts in there, you can have some design do's and don'ts in there, but some of these components can be used inaccessibly. So you have to give the developer a little guidance on where the edge case is. Empower that developer to know when there is the it depends scenario, and also show, like, say you're doing a card, like all the different ways you can create a card accessibly depending on the scenario. So you can't underestimate the power of documentation. It's hugely important. Dedicate a page in your documentation to accessibility links. Allow the developers to learn more, and curate it, keep it updated. And to wrap up, your design system is a cookbook. Cookbooks have personality. React is like a kitchen utensil. You are the cook. Components are your tried and true recipes. Helpful hints in every recipe are key. WCAG is your reference material. And document. So, since you're so patient and listened to all of this, getting on the O'Reilly train a little bit here, we are offering a free 30-day trial membership code. I think it's active tonight. Yeah?
I think it works for about the rest of the month.
Okay, so it works for the rest of the month. And so 30...
Oh, I mean, I think it works for a month.
Works for a month from when you activate it. So what, from when you activate it? Month from today. And so you get access to all our content, like our videos, our live online trainings, our books. If you already have a trial membership going right now, this will extend that membership by 30 days. So if you want to sign up, you can do that, but I'll also thank you, and I'll take questions.